You should have out Lecture 6 notes, which is really just a continuation of Lecture 5. 20 high school students, or 20 high school seniors were interviewed after their prom, and each listed the number of partners they danced with. You have the data set there. Pause and construct a frequency and relative frequency histogram and a chart and relative frequency histogram, and find the mean, median, and mode. So please stop and just do all of that, and we'll check you in a second then. So please stop and do it. Okay, let me go through it here quickly. So I have my class column here, my frequency column here, and my relative frequency column here. And the class to start with is 0 dance partners, and there were 3 out of the 20 who were like that. And so I already know the relative frequency, because the total number is 20, is 3 over 20, which is 0.15. What about the number of seniors who danced with just one partner? There were 6, and so 6 out of 20 gives me a relative frequency of 0.3. 2 dance partners, there were 7 people who had 2 dance partners, so the relative frequency is 7 out of 20, which is 0.35. 3 dance partners, there were, I counted 2, so that's 2 out of 20 gives me a 0.1. I think that's right. And how many danced with 4? The answer is 1, so that's 1 out of 20 is 0.05. And then there was someone who was just tremendously popular who danced with 100. Just one person danced with 100. So that's 1 out of 20 with a relative frequency of 0.05. Okay, so there is my relative frequency chart. I think I called it a diagram. It's really a chart. And let's do next, I guess, is the histogram, of course. So now I threw you a couple of curves in this data set. The first one is you have a class of 0, 1, 2, 3, 4, and then you jump clear to 100. All right, notice in the chart I didn't bother to write, well, the class of 5, there's 0. For the class of 6, there's 0, and go on until I got down to 100. There's no point in doing that, right? There's no frequencies for those classes, so we just leave them out. They aren't really classes in this problem. So I just jumped to 100. So how am I going to do this on my chart? Am I going to start here with 0 and then go to 1 and then 2, 3, 4, and then 5, 6, 7, clear out and clear off the screen going to 100? No, I'm going to do a kind of a standard trick. I go out here a ways, and then we maybe do a little jag like that, which you may have seen in diagrams before. And that just means we're condensing a lot of the axis here so that I can go out here to my data value of 100. Okay, so that was the first little twist I threw you. If you didn't know how to do that, no big deal. I didn't explain how to do it, but I just, it's something you've seen before, and you should just pick that up without any problem. Okay, so this is, again, the class. And, I'm in the previous one, I just wrote class. That's fine, but we should be more descriptive here. So what it really is, so someone walking in on this problem would like to know what those data values are, and it's the number of dance partners, right? So we should really say that. And on the vertical axis, we'll have the relative frequency again. Okay, and let's see. The highest we have is 0.35, and the lowest we have is 0.05. All right, so I'm going to put in the 0.05 first. I'm going to say that 0.05 looks maybe about, it's for 4, maybe it looks about like that. and also for 100. So I'm going to go about right there and back down. Okay, and then let's see, for 3, it's, so, if I put the mark in here, this would be 0.05. Double that to get to 0.1, and that's what we'd have at 3. So if I make it about twice as high, I'll look like that. What about 2 dance partners? It goes all the way up to 0.35, right? So I have, because I have a frequency of 7, so 0.35. Let me come back to that one. Let me do 0 has 0.15. 0.15. So that's going to look about like that, right? Kind of running into my numbers there a little bit. Okay, and then 1 partner is 0.3, so that's double this, double 0.15, right? So that puts me about right to there. And that's 0.3. And then finally 2 is up 0.35, so that's up another 0.05 above that. So it looks about like that, I think. 0.35. So it's good to have the labels on the vertical axis so we can see. In fact, it's essential to have the labels. So here again, this is my I put, when I wipe this stuff off, I put a little solvent on the glass, and sometimes it doesn't want to write. This is the relative frequency histogram. That solvent has to evaporate before I can write well. All right, so we got the relative frequency histogram. We're also asked to find the mean, median, and mode. So the mode is tallest histogram bar is over 2, so it's 2. That was easy. I can also go over here and see, oh, it has the most values. What about the median? Okay, and here's where I've thrown you another curveball, but just about every student I've ever thrown this kind of curveball at, they just knew what to do because they've seen this before in high school or even before. There's actually an even number of data points, right? There are 20 data points here. So when I list them from the lowest, which is 0, out to 100, it turns out that there's no middle value, right? There are 10 numbers on this side and 10 numbers on this side. So in this case, the median equals the number right before and the number right after added up and divide by 2, right? So it's actually the mean of those middle 2 values. And if you go back and look, I'm looking for the 10th and 11th data value. The 10th data value turns out to be a 2, and the 11th data value turns out to be a 2. So we get 2 plus 2 divided by 2, so it still just turns out to be 2, okay? So nothing shocking there, but you do have to average the middle 2 if you have an even number of data points. And the other problem, we had an odd number, so there was a dead middle value. All right, I had 25 data points, so I had 12 on one side, 12 on the other of that middle value. So I didn't have to average. Okay, mean. And I'm going to use the more sophisticated way of computing the mean that we have before, and that is I take each data value, so I'm looking over here at the class, times its relative frequency. So 0 times 0.15 plus 1 times 0.3 plus 2 times 0.35 plus 3 times 0.1 plus 4 times 0.05 plus 100 times 0.05. And if you do that calculation, you get a mean X bar of 6.5. Okay, so the mode, highlight things a little bit here. The mode is 2. the median is 2. And the mean is 6.5. Remember back when I said that what we're looking for here is kind of a one-number summary of the whole data set. We're looking for, in particular, kind of what we think of as a typical value. Well, both the mode and the median represent fairly typical values. You know, if you said, well, how many dance partners did people dance with? Oh, around 2. Makes sense, right? And you look at the histogram and you can see, yeah, 2 is the most common one, and it is kind of in the middle of the values, right? The one that's really way off is the mean. I mean, most people didn't dance anywhere near to the 6.5 partners, except one person danced with a heck of a lot more, right? Well, that 6.5, if you didn't have the data set, and you saw the mode was this, the median was that, and the mean is that, what that would do is that would tell you that, whoa, there's some large data values, or at least one large data value that's throwing everything off, that's skewing everything, we would say. Notice that if this number were even larger, you know, 200 or 300 or whatever, it would not change the mode. The mode would still be 2. It would not change the median or the middle score. It would still be 2. But it would sure change the mean. We could make it change even more and more, right? So the mean is sensitive to extreme values. If you have an extreme value, that can really bring the mean one way or the other, depending on if it's extreme big or extreme small. The mode and the median are not so sensitive to that, and that's worth noting. We will use the mean for most of what we do in the future. For other reasons, it's actually the most powerful measure of center, but it's worth noting that the mode and the median often give you a better idea of what a typical data value is. Okay, let's see here. Well, let me just ask, to finish off, let's ask a couple of empirical probability questions. So what's the empirical probability a senior dances with fewer than 4 partners. Okay. And how about the empirical probability senior dances with more than one partner? Okay. Why don't you pause and see if you can answer those. Okay, come back up here and I will do them. Empirical probability of senior dances with fewer than 4 partners. I can look at the chart or I can look at the histogram here. Fewer than 4 would mean 3, 2, 1, or 0. So I have to add up the areas of all of these bars. Remember, the area of the bar is the height times the width. The width is always 1, so it's the height times 1, so it's really just the height. So I want to add up these areas, and numerically, I just get the height, so I can just maybe come over here and add them up. I'm going to add up 0, 1, 2, and 3, right? So the answer is 0.15 plus 0.3 plus 0.35 plus 0.1, and I don't even know what you get. You get 45, you get 0.9, right? 0.9. So 90% probability the seniors are going to dance with fewer than 4 partners. What about the probability that the senior dances with more than 1 partner? I don't want 0, I don't want 1, I want 2, 3, 4, or 100. So I will look for the area of the bar 2, and that's 0.35, plus 3, and that's 0.1. So 0.35, 0.1. And then 0.05 plus 0.05, and that adds up to what? I think 0.55, right? It looks like a 55% chance that a senior will dance with more than 1 partner.